For our problem 3-7, we need to determine the forces in each member of this truss and determine whether they are intentional compression. Our set external load for this problem is 8 kilonewton. Before we proceed with finding forces in the members, first of all, we need to determine the external reaction. Because this is a simple problem, we don't really need to determine reaction forces for every single external force. We just need either EY or AY. In this case, we're going to try to determine the external reaction force for EY by taking moment about the point A. Going to have EY, and it's counterclockwise and 4 meters away from point A. And then clockwise external reaction force, all equals to 0. Solving for EY, we get our solution as 16 kilonewtons upwards. Now we can start solving for forces in members. Let's start with joint T. In joint T, we have one external force, unknown force in member CD, and another unknown in member ED. Now let's take vertical equilibrium equation to solve for force in member CD. So it's going to be vertical component of the member CD. Take away 8 kilonewtons, all equals to 0. Solving for force CD, we get our solution as 9.238 kilonewtons. And this member is in tension. Now we can sum the forces in extraction to find solution for force ED. It's going to be negative force ED and negative horizontal component of force ED, all equals to 0. Solving for force ED, we get our solution as negative 4.619 kilonewton. Because it's in negative, this means we assumed our vector in the wrong direction. And this member is in compression. Now we can move on to joint C. And at joint C, we just found a reaction force for, or member force for CD, which is 9.238 kilonewtons. Then we have unknown reaction force or force in the member CE, and another unknown in member BC. Now we can sum the forces in y direction to find the value for force CE. So it's going to be horizontal component of force CE, which is simply here, in this case, it's 60 degrees, because we have equilateral triangle, 3 equilateral triangles, and it's going to be negative because we are assuming the vector is in tension, or the member is in tension. And then we have another negative from our member CD, and it's sine 60 as well, all equals to 0. Solving for FCE, we get our solution as negative 9.238 kilonewtons. This means we assumed our force vector in the wrong direction. Switching it over, we get positive, and it also tells us that this member is in compression. Now we can sum the forces in extraction to get our solution for member BC. We're going to have member BC in negative direction, and then positive horizontal component of FCE, which is simply 9.238 times cos 60, and then the horizontal component of CD, which is another cos 60 times 9.238, all equals to 0. Solving for BC, we get our solution as 9.238 kilonewton. and this member is in tension. Now we can draw the free body diagram for joint E. At joint E we have external force EY, just 16 kilonewton. Then we have force ED in compression, force CE in compression, unknown force PE, and then unknown force AE. Let's sum the forces in y direction to find the value for force in member BE. It's going to be horizontal component of member BE, because it's an equilateral triangle, it's going to be sine 60 degrees. And then it's negative because assuming this vector to be in compression. And then horizontal component of EC, and then we have positive 16 kilonewtons from our external direction, all equals to 0. Get our solution as 9.238 kilonewtons. And this member BE is in compression. Now we can sum the forces in x direction to find our solution for member AE. It's going to be positive force AE, negative 4.619 kilonewton. Then horizontal component for member BE and EC. Solving for force AE, get a solution as 4.619 kilonewton. And this member is also in compression. The remaining member is member AB, and this we can easily solve using the joint B. We have unknown vector of AE from member AB. And then for member BC, we have this member in tension. Then we have BE in compression. Now we can sum the forces in vertical direction to find our solution for member E. It's going to be vertical component of E, which is simply sine 60 degrees times force E, because it's resuming it to be downward. It's going to be negative, then positive sine 60 degrees times 9.238 kilonewtons. Pardon me, it'll be negative because member PE is in compression. And then positive 9.238 kilonewtons from member BC, all equals to 0. Solving for member A, we get our solution as positive 4.619 kilonewton, and this member is in compression. There we have solved. For the second part of this problem, we have to determine the maximum force P that can be supported at joint D if the maximum tension in the members can be only 8 kilonewton and compressive force as 6 kilonewton as the max. Okay, to solve this, once again, just like the problem before, we need to determine one of the external forces, and we're going to solve for EY by taking the moment about the point A. It's going to be EY counterclockwise, and then clockwise B, all equal to 0. Solving for EY, we get our solution as 2P. Now, just like before, gonna start with joint D. So at joint D, we have external force P, unknown force member PD, and then unknown force at member ED. I'll start with summing the forces in y direction. We're going to have negative p. We're going to have positive vertical component of CD equals to 0. Also for CD, we get our solution as 1.155p. Now we can sum the forces in x direction to find the force for ED. And we have to do it for all the members in order to determine which member can handle the maximum tensile force and compressive force, and from there we determine which force prevail, either tensile or compressive, to the maximum value of the P. Alright, back to the problem. We have force ED, then we have horizontal component of CD, all equals to 0. Solving for ED, we get our solution as 0.557p. And this member is in compression. The earlier member was in tension. Now we proceed to our next joint, C. C, we have force ED, unknown force BC, and another unknown diagonal force CE. Let's sum the forces in y direction once again. We're going to have sine 60 degrees times force CD, which is 1.155p. And because this member, or this force, or the vertical component is clockwise, it's going to be negative. Oh, pardon me, because it's going downwards, it's going to be negative. And then we have vertical component of force E going upwards, all equals to 0. Solving for force CE, we get our solution as 1.155p. And this member is in compression. Now we do the same for horizontal reaction force. It's going to be negative force BC. Horizontal components for force C and CD, all equals to 0. Solving for force BC, we get our solution as 1.155p. And this member is in tension. Now we'll reach out to joint E. I'm going to sum the forces once again in y direction in order to find the value for force BE. It's going to be, we need vertical component of force BE and vertical component of force EC, all equals to 0. Solving for force BE, we get our solution as 1.155p. And this member is in compression. Now the same idea once again for horizontal member A. We're going to have horizontal component for force member BE and EC. Which simply cancels out. So we don't even have to write it down here. And then left with 0.577p from member ED, all equals to 0. Solving for E, we get our solution as 0.055p. And this is in all compression. Now let's go to member or joint B. We're going to have force BE or PC, an unknown force from member AB. Solve this. Let's do sum in vertical direction because it's the easiest of horizontal and vertical. We're going to have force BE sine 60 to get its vertical component, and then we have sine 60 force BC, pardon me, BE. which is 1.155p, all equals to 0. On force PE, we get our solution as for force AB, we get our solution as 1.155p, and this member is in tension. Now looking at all the values found for our forces, for tension, we have maximum tensile force with 1.55p and compressive force with 1.155p as well. So we know the maximum tensile force we can have is 8. And solving for P, we get our solution for P with maximum tensile force as 6.926. And for compressive force, we know the maximum compressive we can have is 6 kilonewton. And solving for P here, we get our solution as 5.196 kilonewton. Therefore, lowest of these two values will prevail. Otherwise, our compressive force will be more than 6 kilonewton if we decided to take 6.926